But anyway, this should be here. This will cause a directory lookup. So what I'm looking for is that, so anyway, this created a dial plan or a directory request, and then we respond, but it doesn't look like Sipify is catching that. No, that was bragging about how awesome Sipify is. Oops. Let's see if we can. Okay, perfect. So yeah, it is just missing it. So you can see on the initial invite, checking 10.26.0.122 against ACL authoritative. It checks out. It is a proxy according to the authoritative ACL. Found auth IP header of 10.26.0.91 rejected by ACL trusted. Right? If this was an auth by IP, you would see accepted by ACL trusted. And now you know that it was authenticated by IP. So if you accidentally put in the wrong range of IPs, maybe you put in a 24 block when you meant 32 or some other, this is what to look for in that case. Okay, this is all just standard SIP stuff. So it creates this proxy authenticate digest and this random nonce and all that stuff. That's what it sends back to your device saying, I didn't notice or I didn't recognize your IP. Please provide a username, password. Here's some encryption stuff.
After it receives the next one.
Right. So we get back the ACK saying that the endpoint received it, and then we get the invite from the endpoint again with the nonce from before and some other stuff that's related. So now that we've received the invite, we send a 100 trying. Again, we check the ACLs. We check that it's not in the trusted ACL. We're falling back to digest auth, which is what that proxy authorization header is for. And now, hopefully, once you see the actual request. Yeah, perfect. Sending dial plan XML request to this eCall manager. And if you have multiple eCall managers, which I recommend you do, connected to each Freeswitch, it will round robin between them. So you can see after 39 milliseconds, we receive this lovely, easily parsable XML blob. What's important and why it differs from auth by IP is the channel in Freeswitch terms is now created. The memory space is allocated. The data structures are ready to go, right? So what can we do? The first thing we do is we say it's for context 2. We're going to park it. We do a log line, blah, blah, blah. So now we're going to export, which just means set some channel variables, right? Freeswitch allows us to set custom key value pairs on a channel that will be there for the length of the call. We prefix ours with eCall manager underscore, and then we set eCall manager node, bridge ID, don't worry about. The one we care about, where is it? We set some ringback in this case. We set transfer ringback, and then we park it. Right, so we actually haven't done anything to the call other than just set some variables and park the call and set some ring ready stuff. Okay, and park in this case is not like putting it in a parking spot to be retrieved later. Right, park is just, I've heard you, I'll get back to you. It'd be like a 202 in HTTP land, right? So now it parsed it properly, and now Freeswitch is going to walk through that and actually execute the various actions it's supposed to. So meanwhile, eCall manager receives the OK from Freeswitch saying it accepted the XML and has now sent the route win to the application that won. So now we're waiting for commands back from the winning application. All right, so we set some channel variables. And what's important about this is when you do auth by IP, you don't have this authentication step, so these variables don't get set, which is how we can differentiate whether a route request came in via ACL authentication or username password authentication, right? Because we never went through this phase with IP off, nothing will be set on the channel that we're looking for. Which means on the route request, when we look to see if these variables are there, we can know whether we need to look up the IP or not. All right, so we park. So now we're going to start seeing some commands getting sent in. So in this case, we've got a setbar multi, which is just setting a bunch at once. And so you can see we've got the username of who called, the realm of who called, the account ID of who called, the authorizing ID. This would be the device ID, right? So these are all couch document IDs. The authorizing type, it was a device versus a carrier versus sysinfo, which is left over from trunk store. I hate trunk store. The owner, the user ID of who's making the call, right? So this is all caller kazoo information that we are now setting on the channel. This is all accessible in the CDRs, right? All of this stuff that you set on the channels are accessible in the CDRs. They're accessible on every channel event that is related to this call, right? So that's how we pass along state about, kazoo state about the call. So now when the route request goes out, we will have the account ID as well as some other information that will identify it as an authentic call and that we should proceed with processing it. When it does auth by IP, we don't have that account information. And so we have to use other things like the DID dialed or the IP that it came in on to look up how to route that particular call. Does that make sense? So here it's just setting. Okay, so now we're executing the extension for the dialed number. And then we should see, this all becomes like the Matrix where you just start skipping everything. Blonde, brunette, redhead, yeah. Yeah, blah, 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 blah. I'm just trying to find where we... So again, all these commands are being executed by kazoo against the Freeswitch channel. This is not Freeswitch dial plan executing. Just want to find where it tries to bridge. Oh yeah, there it is. Okay, so we're going to bridge. In this case, this was testing a carrier feature. Bring this down so I can actually reach it. So this whole bridge string, right? Specific channel variables, or global channel variables, specific channel, because you can have multiple, you could do multiple paths to try. So this, in this case, was generated by the carrier configuration. If instead you had tried to bridge to user at realm because you're bridging to another device, eCall Manager, which is maintaining the registration table that it gets populated by Camilio, will take that user at realm and convert it into the user at the contact string, basically. And then based on the rules, it will replace the username with the dialed number if it's a PBX, or this will be the user at IP, maybe an FS path, some other routing information, right? But Freeswitch does not store any of this in its local DBs anymore, right? This is all stored in kazoo. Anytime an application says bridge to user at realm, eCall Manager takes user at realm and converts it into something at IP address, depending on how the routing rules are set up for that particular endpoint. So anytime you see eCall manager underscore on a channel variable, that's kazoo specific. Everything else, like SIP auth username, it's going to be the Freeswitch specific parameters for a bridge, for whatever the command might be. So you can see the command comes in, Freeswitch parses it, and then it spins up the new channel. The SDP information if you're debugging audio issues, and then the corresponding invite. Okay, so that's the debug log. Should be familiar. The SIPify is pretty good, especially if you just need the SIP traffic. Might have to issue some pull requests to get the dial plan fetches and whatnot in there. But are there any questions on this? It'll make a lot more sense once we start making phone calls and things like that. Be a little more concrete.